Welcome back to G Fun Facts Online, your go-to spot for the most amazing and mind-blowing facts from around the web. Today, we're diving deep into a world that's usually the stuff of science fiction, but is rapidly becoming our reality. We're talking about robots? Not just any robots, but super advanced robotic systems venturing into places humans can't, or should NT go. Think deep seas, disaster zones, maybe even other planets. It's a thrilling field, so buckle up. So what's making these robots so incredibly smart and capable? A huge part of it is artificial intelligence, or AI. AI is like the brain behind the machine, revolutionizing how robots see, navigate, and interact with the world around them. First up, let's talk about how these robots perceive their surroundings. They're not just relying on a single camera. They're packed with sensors, cameras, LiDAR, which is like radar but with light, and sonar. AI models, especially something called convolutional neural networks, help them process all this data. It's like giving them superhuman senses to understand complex scenes, recognize objects, and spot obstacles, even in tricky conditions. Imagine a robot that can see in the dark or through fog better than we can. Now, if a robot can see, it also needs to know where it is and where it's going, right? That's where SLAM comes in. It stands for simultaneous localization and mapping. This is super cool technology that allows a robot to build a map of an unknown place, while at the same time, figuring out its own position on that map. Think about exploring a new cave and drawing a map as you go, all while pinpointing your exact location. Modern SLAM systems are even smarter, combining LiDAR and vision, and using AI to interpret what they see, identify objects, and even understand the meaning of things in their environment. It's like they're not just mapping a room, but understanding it's a kitchen with a table and chairs. And what about navigating tricky paths? AI helps with that too through adaptive path planning. Using techniques like reinforcement learning, robots can actually learn from experience. If they encounter an unexpected obstacle or changing terrain, they can adapt their route in real time. It's like having a super smart GPS that not only finds the quickest route, but also the safest, constantly learning and adjusting. Researchers are even teaching robots to balance speed with safety, finding clever shortcuts while making sure they get there in one piece. But wait, there's more. We're seeing a rise in what's called cross-domain robotics. These are robots that aren't limited to just land, or just air, or just water. Oh no, these are the triathletes of the robot world. Imagine amphibious robotic dogs that can run on land and then swim efficiently, just like a real animal. Or picture robots that can fly, drive, and then, get this, perch on vertical surfaces like a gecko. How incredible would that be for disaster rescue or secret reconnaissance missions? And it's not just about individual multi-talented robots. Scientists are also working on multimodal systems. This means different types of robots, like drones in the air, rovers on the ground, and robotic boats on the water, all working together, sharing information, and coordinating their actions to achieve complex goals. Imagine a search and rescue operation where a drone spots something from above, alerts a ground robot to investigate closer, while a water-based robot checks the nearby shoreline. The possibilities are endless. Of course, a major reason for developing these advanced robots is to send them into extreme environments, places too dangerous or simply impossible for humans to reach. We're talking about nuclear decommissioning sites, the crushing pressures of the deep sea, the vacuum of space, or the heart of a collapsed building after an earthquake. To survive these conditions, engineers are designing robots to be incredibly robust. They can withstand extreme temperatures, high pressures, radiation, and even contact with hazardous materials. They might have tracks for rough terrain, legs for climbing, or even self-healing capabilities. Think of robots exploring Mars, inspecting deep-sea oil rigs, or venturing into volcanic lava fields. These aren't just tools. They're our brave robotic explorers. Now, with robots getting so advanced, how do we humans fit into the picture? Human-robot interaction and collaboration are getting a serious upgrade. You might have heard of cobots, collaborative robots designed to work safely right alongside humans in factories or labs. They have intuitive interfaces and extra safety features, making them great work buddies. For robots in far-off or dangerous places, teleoperation is key. This is where we control robots remotely, And it's getting much more intuitive thanks to things like augmented reality, AR, and virtual reality VR interfaces. Imagine putting on a VR headset and feeling like you are the robot, seeing what it sees, controlling its movements precisely. There's also a focus on shared autonomy, where a robot can operate on its own, but a human can step in and take control when needed. It's the best of both worlds. And how about controlling not one, but many robots? That's where swarm robotics comes in. Picture a disaster zone. Instead of one big, clunky robot, you could have a swarm of smaller, agile robots working together. They can spread out, cover more ground, gather information, and support rescue operations. Researchers are even working on ways for a single human operator to easily control and coordinate whole teams of these robots across different domains. It's like being the conductor of a robotic orchestra. Of course, none of this would be possible without incredible sensors and end effectors. End effectors are basically the robot's hands or grippers. Advanced sensors give robots richer and more accurate data about their world. Better vision, tactile feedback, a sense of touch, and environmental awareness. And when it comes to actually doing things, robotic arms and grippers are becoming incredibly dexterous. They're being designed to handle all sorts of objects, soft, fragile, slippery, or even weirdly shaped. This is crucial for tasks from manufacturing delicate electronics to assisting in surgery. So, what does the future hold? Well, hang on to your hats, because by 2025 and beyond, things are set to get even more exciting. Expect to see hyper-intelligent robots. AI will enable them to solve much more complex problems, understand natural language more effectively, and maybe even show sparks of creative thinking. Autonomous mobility will also hit new heights, with robots navigating ever more complex and dynamic environments all by themselves. We'll also see big leaps in soft robotics. Think robots made of flexible materials, capable of very delicate tasks. This could revolutionize handling fragile items in food processing or even in healthcare, like assisting with gentle patient care. And finally, bio-inspired designs will continue to flourish. Robots that mimic animal movement and behavior will keep providing amazing solutions for tricky terrains and complex actions. Think robots that slither like snakes, climb like monkeys, or swim like fish. These advancements are truly transforming industries everywhere, from manufacturing and logistics to healthcare, farming, environmental monitoring, and even space exploration. Robots are paving the way to take on increasingly complex and critical tasks in all sorts of challenging environments, making our world safer, more efficient, and opening up new frontiers of discovery. Well, that's all the time we have for today on G Fun Facts Online. I hope you're as amazed by the world of advanced robotics as I am. Join us next time for more fascinating facts. Until then, stay curious,